Okay, here's the check expect that I wrote. I said check expect. Remember, I had prescribed that the function argument had to be string length. Well, that is a function from string to natural. So that means x has to be string and y is going to be natural. So that means the list argument to map to has to be a list of string. A, B, C, D, E, F, for example. And what we get back is a list of the string lengths, list 1, 2, 3. Let's check that to see it works. Great. Now, just a quick review so far. I've introduced 3 new pieces of notation. You can write open paren list of followed by any type and a closed paren, and that means a list of that type. In a function signature, if you have to include the signature of a function, you just put parentheses around that function signature. And I've also introduced this notion of type parameter, which allows you to express these kinds of consistency relationships in signatures where you're saying, for example, in the case of map2, this function can consume anything it wants, but whatever it consumes, you better give me a list of that same thing. Let's do one more. Here's filter 2 that we started on. So let's see, it consumes 2 arguments. So the signature starts out looking like this. And what do we know? Well, let's look at the result position. It produces empty sometimes and cons other times. So therefore, the thing it's producing is clearly a list. A list of something, we don't know quite what. Let's see, let's look at its ln argument. Here we take the first of ln, here we take the first of ln, and here we take the rest of ln, and here we take the rest of ln. Ln is pretty clearly a list. So it's a list of something. What about pred? Well, here we pass pred in the natural recursion, so that doesn't tell us anything about its type. But here we call pred as a one-argument function. So pred is clearly a one-argument function. So we'll write this. Okay. Well, let's keep looking at pred since we're right there. Oh, this is interesting. Notice that pred is used in the question expression part of an if. Because this call to pred appears as the question of an if, what does pred have to return? It has to return a Boolean, right? If wants its question to produce either true or false. So this is telling us that pred has to produce a Boolean. Okay, let's look at the argument to pred. I see, the argument to pred is an element of the list. So that's telling us that this position and this position are going to be the same. Do we know anything more specific about that position? Let's go look. Let's see, here we call first of ln, it goes directly to pred, so that doesn't tell us anything more specific. It doesn't really look like filter 2 itself ever looks at the elements of the list. Here it passes it to pred, here it sticks it in the result list. Filter 2 never itself operates with some other primitive on the elements of the list. So what that's saying is the elements of the list can be anything except that pred has to be prepared to consume them as its argument. That's what this is saying here, is it's saying whatever first of ln produces, pred must be able to consume. Now we've only got one thing left, which is the type of the elements of the result list. Well, this cons is the only place where we add elements to the result list. Here we just produce empty. Here we add elements to the result list. What do we know about the type of those elements? Oh, look, the only thing that ever gets put in the result list is an element of the consumed list. what that's saying is, whatever comes in is the same type that goes out. So that means that this is also X. If you call filter 2 with a list of numbers, you get back a list of numbers. If you call filter 2 with a list of images, you get back a list of image. If you call filter 2 with a list of string, you get back a list of string. So there you go. That's the process of inferring the signature for an abstract function by looking at the code for the abstract function and piece by piece inferring what you can about the types of the arguments the abstract function consumes and the type of the result the abstract function produces. And using type parameters, these x's and y's, in places where the abstract function is willing to consume data of any type, but using x and y repeatedly in a single signature to talk about constraints where the abstract function is willing to consume any type, but the type of two different parts of its signature must be consistent.